Alright guys, so I know that Monday we didn't really go over the Hardy-Weinberg equations, and so I wanted to do that in a video today. So we are going to use the data gathered from class 1. What we did in our chart on Monday was we gathered the raw data, which is totally fine. But when we're talking about Hardy-Weinberg, we are inputting frequency of alleles. And so I'm correcting the mistakes I made by letting y'all do the raw data instead of the frequency. That's my bad. So your charts are still fine. I'm just going over it now so that you understand what we're looking at. So if you have any questions about this, shoot me an email. We will be doing bonus questions, a packet of bonus questions with these Hardy-Weinberg equations. So I want to go over it, and that way you have this video for reference when we do these bonus questions, and you can always come see me. So we're gonna look at the equations and what they mean, and then we're gonna get into how to find the information based on those equations. So it shouldn't take us too long, so I'm gonna start it now. So the first equation that we're gonna need is P plus Q equals 1. So here. So we talked about what P and Q and P squared and Q squared and 2PQ meant. So you've got P being the dominant, Q being the recessive. P squared is the homozygous dominant, Q squared is the homozygous recessive, and 2PQ is heterozygous. Good with that, right? So what we do here, we're not going to input the numbers that are the raw data. What we're going to do is we're going to take the population total, which in this case, from the data that I'm using, our class today had 15. So your population total is 15. So for the first one, the PTC tasting, they had 5 that did not taste and 10 that did. So we're gonna always start, when you're looking for P and Q, you're always going to start with recessive. And that is because in order for the recessive gene to manifest and to be the phenotypic projection, you have to have 2 recessive alleles. So whereas if we were to find P, I said that backwards. We're looking for Q. We're going to start with Q. We're going to start with the recessive. So if we were trying to find P this way, we wouldn't know if they were homozygous dominant or heterozygous, because there are 2 ways that the dominant allele can present, but only 1 that the recessive allele can. So we're going to start with Q. So what you do, I'm going to angle this a little bit so you can see. I hope it's not backwards, but it might be. So this first column here, those are the dominants, and those are the recessives. So always start with the recessive. So what you do in order to find Q is you take your population total, which in this case is 15, and you take 5 divided by 15. Okay? So 5 divided by 15 equals, in this case, it is 0.33. So what you've just found is the homozygous recessive, right? So homozygous recessive isn't Q, it's Q squared. So 0.33 is Q squared. So in order to go here, it can't be Q squared, it has to be Q. So you take the square root of both sides. So square root, Q is equal to 0.57. Okay? So from there, now you've got Q. So you're not going to find P the same way. What you're going to do is you're going to take Q that you just found and do P plus 0.57, because that is Q, equals 1, right? Because here's our equation that we're using right now. So subtract 0.57, subtract 0.57, so P is equal to 0.43. Okay? Good with it? Alright. So now you plug that in to another equation to get the frequency of homozygous dominant, homozygous recessive, and heterozygous. And that's the other Hardy-Weinberg equation. So we're done with this one. We've used this one. So the next equation that we're looking at is P squared plus 2PQ plus Q squared equals 1. So Q is equal to 0.5. Alright, so you've got P is 0.43, Q is 0.57. So we're going to have 0.43 squared. We're going to do plus equals 1. Okay. All right. So 0.43 squared plus 2 times 0.43 times 0.57 plus 0.57 squared. So all you've done for this longer equation is input P and Q. So now what you do is you take out your calculator and you do the math. So we've got 0.43 squared equals 0.185. So I'm trying to color code it for you. So in your chart up there, it's going to say 0.185. All right. Now you've got 2PQ, so 2PQ, so 2 times 0.43 plus 0.57. That's going to be 0.49. So plus 0.49. So then you've got plus 0.57 squared. I'm not adding them up yet. I'm just getting you each section. So 0.57 squared is equal to 0.32. 325 if you want to get technical. So plus 0.325. So you've got all of that, and it should equal 1. Equals 1. Here with it? Okay. So now let's add up these. So 0.185 plus 0.49 plus 0.325 equals 1 on the dot. Okay? So that all comes down to 1, and it equals 1, and we're happy, and the Hardy-Weinberg principles and equations are met. So I will do another one just to go through it one more time. I can pull random numbers if you would rather me do that, or I can continue to go with this. I know you can't answer me because this is a video, not not a live chat. So let's just do one more with the 15, and then if you have any questions from there, shoot me an email and we'll go over it again, okay? So I'm gonna erase all of this except for the population total at the top, and then we'll go through it again. All right, so we've got our population of 15. So I'm gonna try to do it in the markers color this time. So we will do P is blue, Q will be green, and then 2PQ we'll do in pink again. Alright, so right now, on our next one, let's do mid-digit hair, because those numbers were a little different. So, they've got, in mid-digit hair, they've got 9 of 15 that were recessive. So we're going to go to 9 divided by 15 equals 0.6. But what we've just found is Q squared, remember, because what we're looking at with recessive before we square root it is the square, because we're looking at just the homozygous recessive, because that's the only way that that recessive gene is going to manifest. So 0.6 equals Q squared. So square root. Let me find that button on this calculator. 0.6. All right, 0.77 is the square root. So Q is 0.77. So now go to our P plus Q equals 1. So we're going to subtract 0.77. Excuse me. We're going to do 1 minus 0.77, and that's going to give you 0.23. And that's P. That's blue. Point 2, 3. Alright? So now we're going to take this and plug it in to Q squared equals. Alright, so now let's take these and plug them in down here. So you've got .23 squared plus 2 times 0.23 times 0.77 plus 0.77 squared. So let's find 0.23 squared. 0.53. 2 times 0.23 times 0.77, 0.35, plus 0.77 squared, .053, my bad. This is plus 0.35. And then 0.77 squared plus 0.59. Okay? Sorry, I left out a 0 on the front of that, 0.53. All right, so now we're gonna add these together and it should be 1, because that's what the equation says, right? Up here should be 1. So 0.053 plus 0.35 plus 0.59, 0.99. So 1. Okay? All right. So, population total of 15. Recessive, number of recessives over the population total gives you Q squared. So in order to find Q, you square root, and in this case, you get 0.77. You plug 0.77 into P plus Q equals 1, get 0.23. Take these numbers to get this one down here. So P squared plus 2PQ plus Q squared. That's these three. And that all together equals 1. So that's how the Hardy-Weinberg equations work. If you have any questions, shoot me an email. See me after class one day. I'll be sending out these bonus questions. I'm not real sure when we're going to do that, but I feel like it'll be soon. So I need to get with the other labs and see what we're doing on that. But outside of that, if you have any questions, just let me know and I'll answer them. Thanks, guys. Have a great day. Bye.